Bonjour, je m'appelle Edson YANAGA, je suis brésilien japonais, je suis étonné par les Français. Merci beaucoup pour être ici. DevOps France est merveilleux et félicitations à vous. Et c'est correct? Oui? Merci. That's all the French I had, so I don't know if it was right. Okay, but as I said, I'm Brazilian, but my grandparents are Japanese, and I'm very happy to be here for the first time in France. First time DevOps France, of course. And I'm a director of developer experience at Red Hat. My Twitter handle is at YANAGA. I talk a lot about DevOps, microservices, domain-driven design, best coding practices, so that's my duty. And today I'm going to be talking to you from my deployment experience. I'll be giving you some insight about different deployment options with Kubernetes OpenShift, from the very basic to the most advanced, even so advanced that most of the companies they aren't using that yet. But I think it's very interesting to present that to you, so maybe you can see what can you be using in the future. So I'm also a Java champion and a Microsoft MVP, which is a kind of weird combination, but the world is getting weirder, right? I also like to share to you, yesterday I gave this tip on my talk. I've just written a book from O'Reilly, Migrating to Microservices Databases. It's available for free on the developers.redhat.com website. And I don't know if we might have some few copies left at the Red Hat booth. No, we don't have any copies left, okay? But you can get the ebook for free, okay? Just go to the website. It's available for download. Not only the book, but a lot of cheat sheets and all of the Red Hat products and projects. They're available for free for development if you register on our website, okay? That's the tip. And the first part of my talk, the first 2 or 3 minutes, is the same as yesterday. I don't know if anybody was there too. But I always like to start my talks with this quote from Forbes. Now, every company is a software company because we live in a different world. We live in a digital world, and of course, in a digital economy. And I used to think that economy was had everything to do about money. But after reading some economy books, particularly behavior economy books, I realized that economy has nothing to do with money, but has everything to do with how people interact with each other. So to understand economy, we must understand how people interact with each other. And some great examples of this new digital economy that we have today, there's this new digital way that people interact with each other, are that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies, they only exist because of software. So software is changing the world. So we developers, I believe that we are the most important people in this planet right now, because if anything is going to happen on the next 1,000 years, is because a software developer is going to make it happen. So congratulations to all of us, because we can make the difference in this new world. And I know that with our experience developing software, we know that great feeling when we can deploy something successfully into production, and we can see that we're improving the users, the people's lives with our software. But we also know that feeling of being miserable using software that is not good enough. So some years ago, I made a decision. I decided I didn't want to make people feel miserable. So I believe that we all can make this choice too, right? But today, since we're talking about deployment, the main topic, the main subject here is DevOps. We have to deliver software faster into production. I will not explain what is DevOps or what are the concepts and everything else. I just want to point to you how important is the feedback loop in anything that we do in our lives, and of course, particularly in DevOps, in software development process, and releasing software into production. Because imagine the software development process is basically we have a problem. Then when we have a problem, we create a lot of different hypotheses in our minds. Then we quickly discard some. This is too hard. This won't work. I don't know this technology, maybe. Then we quickly pick some hypotheses for solving your problem. But the only real way for you to know if your hypothesis is going to work in your software is to deploy that into production. Because even if when you're coding, even when it's already coded, you need to make sure that your idea will survive production. And for that, you need to deploy your software into production. But sometimes you take too much time from having the idea, from coding and deploying to production. Then when the code is deployed to production, you don't even remember what you did like 6 months ago, 1 year ago, or 1 week ago. So we have a very limited amount of capacity to be handling information in our minds. So it's very important that we can shorten the feedback loop. So the faster we deploy software into production, the best is the quality of the software that we deploy. Because we can quickly access. So imagine if instead of waiting 6 months or 2 months or 1 month for delivering software into production, if we just could commit and deploy, we could quickly assess, oh, am I doing the right thing right? Deploying to production, oh, it's not working quite well. I was expecting results, not working quite well. Maybe I can change this. You just commit and deploy again. It's very easy to validate your ideas, both solution ideas that you have in your mind and both business ideas, because even the business people, they don't know exactly what is going to work into production. So if you could quickly assess if your idea is going to do the right thing in production, maybe the quality of, maybe no, for sure, the quality of your software will dramatically improve. Technically, this term is called the batch size. The batch size is the amount of things that you deploy into production in each one of your releases. And the smaller the batch size, the faster your cycle time. So the faster you deploy things into production. So everything, if anybody ever studied Kanban, these terms are all related. So if you reduce the batch size, you reduce the lead time, you reduce the cycle time, so you can deliver more frequently, the better. But even if you try to reduce your batch size, you have something called maintenance window, which is the time frame that the ops guy lets you deploy things into production. So that's the moment, because usually you disrupt user into production when you deploy software. To solve this problem, to reduce your batch size, to have a smaller batch size than your maintenance window, you need zero downtime. So all of the techniques that I'm going to demo you today are about zero downtime deployments, and we have some requirements. So this presentation, the demos that I'm going to show to you, they are all zero downtime scenarios. I'll present to you how to do that from the basics to the most advanced, and the most basic one is the blue-green deployments, which is basically you have traditionally, you have clients issuing requests to your environments, your blue environments. You add another component to your architecture, proxy, which is just handling requests on behalf of something. If you add a proxy in your architecture, then you're able just like to replicate your environments. Now you have 2 different environments. And the cool thing about that, I just realized, I was talking about blue-green deployments, then the last time I talked about it, one person after the talk came to me and said, what is that blue-red thing that you were talking about? I didn't realize he was colorblind. And maybe blue-green is not the perfect choice of colors, okay? But blue-green deployments, and if you're using a blue-green deployment, then you have 2 equal environments. Each one of them are capable of handling 100% of your requests into production. So how do you update that? You just ask the proxy to remove the green deployment from production. You stop the servers, copy the artifacts, start the servers, warm them up depending on your technology. In Java, at least, you need to warm up your servers because they might take some time to be able to handle 100% of your requests in production very quickly. So when you do that, when everything's okay, you can ask the proxy to route the request to the green deployment and disable the request to the blue deployment. You do the same process again, stop the artifacts, copy, start it up, warm it up. When everything's okay, you deploy that in production, okay? So this is also safe because if anything went wrong with the green deployment, the blue deployment is still into production. You just don't have to route the requests back to the new version, so you can safely roll back versions into deployments. Yesterday I talked about how to handle state during these blue-green deployments. Today I'm gonna show you just how to deploy that into production using different techniques. And Another interesting kind of deployments, which is an improvement over blue-green deployments, is what we call Canary deployments. And for those of you that are not aware of this analogy, Canary deployments are used to be used in the coal mines because you know, when you're in the coal mines, when you're cracking the walls, sometimes, and when you crack a wall, you have some toxic gases in the coal mines, and most of these gases, they don't smell anything, so you might die without knowing. So the good thing about the Canary is that the Canary sinks, and second, it dies very fast. So, yeah, which is a good feature. Yeah. So for the coal miners, they're just walking with the Canary, and the Canary is singing and everything else, because suddenly, if the Canary stops to sing, then run away, because you might be the next one. So that's the analogy, but I didn't realize that the people protecting animals, they didn't like the use of canaries for that. So now we have machines for doing the same. They just beep when you have toxic gases near you. But that's the analogy that we use when we're trying to deploy, because, you know, it's kind of risky. Even if you test that before routing the request back to the production to the new deployment, some business behavior might not be right, so you don't want to have 100% of your users having the same error at the same time. So how do we do a Canary deployment? We just test first with a small amount of users, the new deployment, check if everything is okay. Then we start increasing the amount of requests that we go to the new deployment until 20%, 30%. Is everything okay? Then you go testing and testing and testing until you have 100% of your requests into your new deployment. Then you know that everything is okay, because sometimes it's not even bad behavior. Sometimes you just deploy a new version into production and it just gets slow. It is correct, but it doesn't perform well, so you won't be able to handle 100% of your requests, and you might need to roll back the version. So that's why you use a Canary. So Canary, basically, you still have a blue-green deployment, you still have a proxy, and you just increasingly keeps increasing the load or the amount of requests that you have into the new deployment. And if anything goes wrong with the Canary, you just roll back the version. The blue deployment still has the previous version. Nothing happened. You disrupted the least possible amount of users in production, right? Another variation of the Canary deployment is what we call the rolling upgrade, which is an upgrade to the Canary deployment strategy. When we're doing rolling upgrades, you still use a Canary to check if everything goes wrong, but then it assumes that you won't be having just one or two deployment environments into production. You might have like at least 3. When you're having a rolling upgrade, then you decide to release a new green version, then you just do that. You do what? You just update the first version. If everything's okay, you update the next deployment. Then if everything's okay, you update the next deployment. And in the modern platforms for container deployment like Kubernetes, it automatically checks for you. You're saying that, oh, I need at least 5 replicas running into production at any given moment. So if you're going to update a version, I need you to first, you spin up new copies of that. And when this copy is okay, then you might take one. When this copy is okay, you might take another one. So that's a kind of rolling upgrade. Then you guarantee that if you say that I need at least 5 replicas running into production, Kubernetes, for example, guarantees to you that you will always have at least 5 replicas of any given application running into production at a given moment. So it's always safest. So it's a rolling upgrade is a Canary, plus the guarantee that you will always have at least this amount of replicas running into production. Okay? So this is the basics. So let's start to talk about A/B testing. Some people think that A/B testing is simple. In fact, it's not. It's the most advanced scenario for deployment, because when you're A/B testing, there's no clear new version of software, because when you're doing A/B testing, you just have 2 different business hypotheses or even implementation hypotheses. You just don't know which one is better. So you don't know if this implementation is better than the other, but you want test. The best way to check if anything is better than the other is deploying that into production. Well, so when you're doing A/B testing, you deploy this implementation and you deploy the other implementation also into production. Then you need advanced monitoring. It's just not enough to know if it's running. You also need some business metrics to know if I'm checking if I'm selling more. You need which version is selling more. Okay, the classic example that people give is if I change the color of the button, or if I change the position of the button, or maybe Amazon does that, for example. Maybe if I change the recommendation engine for this kind of user, is it going to sell more or less? But the only way to check, you need to monitor if you're selling more on this version or the other version. So if you're thinking about doing A/B testing into your environments, you need a very advanced monitoring platform before that. But if you already do, then A/B testing is very useful. For A/B testing, you have two different kinds of A/B testing. You have what I say dumb A/B testing, which is the kind of thing that can be automated by infrastructure. And if you want to do dumb A/B testing, which is just saying that I want 50% of my requests to go to this deployment A and 50% of the requests to go to this deployment B, then Kubernetes does not have a feature for that, but OpenShift does. So we can route 50% of the requests to each one of the deployments, and you can monitor that. But if you want to do what I say smart A/B testing, then you need another kind of tools for doing this kind of deployments. So basically, with the first option for you to doing advanced A/B testing or smart A/B testing is to deploy a smart router in front of your, it's not just a dumb router anymore, you need a smart router. And when I say smart router, it's because the smart router has access to business logic, so it's programmable. So you might want to check first, I want to check if in the iOS users it has a different demographics. So I want to test this hypothesis just on the iOS users. Or maybe I'm testing my new recommendation engine just here for French people. So you can add this kind of business logic in a smart router, but a dumb router, all it understands is like HTTP request or IP address or this kind of thing. So it's not that useful for advanced A/B testing. You can deploy a smart router. The most popular one in the market these days for smart routing is Zuul, which is an implementation from Netflix. I'll show you today. And the other possibility for doing smart A/B testing is to use feature toggles, which is basically, how do I say, a dynamic if that you can add to your application. So you can test, you can have different implementations in your code, and you can dynamically switch for the users. If the users comes from iOS and come from France, I want you to use this implementation in runtime, and the other ones, I want you to use the other one. So I'll explain later the pros and cons of each one of these approaches. But the two most popular frameworks that we have for feature toggles today is probably FF4J, which is feature flipping 4J, and Toggle Z. These are the most popular approaches. And the demo that I'm going to show to you is FF4J because I think that particularly it's more mature, okay? It has more features, has a nice console, different storage mechanisms, but enough of talking, I want to show you things running. So all the demos that I'm going to show to you today are running on Kubernetes, and on top of that we're running Red Hat OpenShift. And if you want to try, the thing that people complain about Kubernetes particularly is that it's very hard to install, to test or try any Kubernetes deployments. So just to try to make it easy, we on the developers.redhat.com we created the Red Hat Container Development Kit, which is just a VM that you install on your machine. It has a lot of tools. Currently it's a Vagrant box. You install that. It is a full-featured Kubernetes cluster and an OpenShift cluster running on your machine. Okay. It technically or theoretically it could run on 3 GB of memory. But I strongly recommend you to do like at least 6 or 8. At least I need 8 because I have a lot of things running on this VM to show you. But it works, and you can try Kubernetes and OpenShift inside your own notebook. Okay. So what do I have here? I have the OpenShift web console. I'm going to do some deployments. In the beginning, I'll just create a simple deployment, which is a basic Kubernetes feature. You don't need OpenShift for that. So I have a very simple application here, and I'm just gonna check. Here I have a very simple page. It just have a blue background, and I'm going OCB blue, which is just typing some OpenShift commands because I don't want to be typing all of that doing a live demo because it's risky. But you can see in cyan the color. Oh, fail. Oh, I don't have a project, so Let's first create a project. OC, new project, deploy master. Okay, now it's, so now let's build. Now it's building a Docker image with the files that I have. It's inputting that to Kubernetes. Then Kubernetes just deploy that. And one of the cool features of the OpenShift environment is that OpenShift has dynamic routes on top of Kubernetes. So you can dynamically change the deployments that you're going to route your request. That's an OpenShift's own feature. So what I show you today is now I have a project called Deploy Master. And you see here I have a new deployment configuration. I have here blue running. I have here an DNS name that I can use to access. If I change that, which is just cool because DNS is not working, but I'll just fix that. Okay, when DNS doesn't work for you, you just do that, okay? Which is fine because it was working before doing a live demo. It's working, okay? If you just fake your DNS, it's working with a blue deployment, right? So let's try to change. I want to change the background color and do a new deployment. So I'm gonna change here. So it's not blue anymore. I want cyan. And so it's gonna say hello from cyan, right? But before that, I want to show you what? I want to scale automatically the amount of instances that I have into production. So with Kubernetes and OpenShift, it's very easy. I want to scale that to 4, 5. So I ask, and then Kubernetes will be creating the pods for me. The yellow means it's creating. The orange, sorry. But when everything is blue, it means that it's ready to go into production. But if I just hit it, it's working. When you want it to fail, it doesn't. And I'm gonna now deploy the new version. I'm just gonna package my project, or else it won't change anything. And start a new build. And if you see here in the console, OpenShift shows you that you have a new build in progress. And when the build is finished, the Docker image is finished, Kubernetes is going to deploy the new version into production. Okay, now you see, you have the current version and the new version. It's spinning up the pods, 3, 4 to 3. Then when the new pods get ready to handle the request into production, Kubernetes gets the old version down. So if I say that, if I didn't configure that, but if I said that I need at least 3 or 4 or 5 pods into production at any given moment, Kubernetes will guarantee that for me. But the problem, it was too fast. Okay, but the problem is that when I just release a new version into production, sometimes my application, the application here is too simple, it's very fast. But if I have a big application, you know that sometimes the application server is already up, port 8080 or 80 is already responding to requests, but the application is not ready. It's just taking a long time to reply. So if you want to check that, I only want my new instances to be answering requests when it's already warmed up, when it's fast enough. For that, you have a cool feature of Kubernetes, which you can configure here for the interface of OpenShift, which is called Readyness Probe and Liveness Probe. Okay, Liveness Probe is that, is my application live? Is it running? And a Readyness Probe is that, is my application ready to answer requests? Is it fast enough for that? So I'm going to add both. A Readyness Probe with the default parameters of one timeout of 1 second and a liveness probe of 1 second, so Kubernetes can check if my application is really running. And I just need to add the default here for one second timeout. If my application takes more than 1 second to reply my request, it will be considered to be non-responsive. So Kubernetes will get this instance out of the cluster. Okay. So that's how it works. So if I get now, Kubernetes is doing a new deployment. And when it's doing a new deployment, it is already checking if the application is live. So previously, you would be able to see for some requests, you would have a long response time, or else you would have an error, because the application was not ready. But now that I added health checks, I can guarantee that 100% of the requests that I'm going to issue to my deployments will be okay. Right? This is the basic rolling upgrade feature with health checks and liveness checks of Kubernetes. But let's try to do something cooler, not just rolling upgrades. I want to do blue-green deployments. And so first, I'll create a new deployment. First, if I have the source code on my machine and I want to deploy that into production, it's okay. But maybe we already have a Docker image which was built by my continuous integration server, just like a Jenkins, and it will already be published in my internal repository because I'll be using some kind of Nexus repository or a Docker registry or Artifactory repository. So I'll already be storing. So I'll just get a ready to run image. I'll get here, I'll say YANAGA, deploy master, and I want to deploy a green image. So it's the same application, but with a green background. I'll say that this is a green application, and I'll just create that. Okay, when I create it, you see I have a blue deployment already running, and I have a green deployment which is just instantiating. By default, my applications are not exposed to external clients. So if I want to do that, I need to create a router, which is an entry point on the OpenShift cluster that enables your external users to be accessing your endpoints. Why do you do that? Because by default, you want to be secure. You don't want your application to be exposed. So you need to create a route for that, because many servers, like a database server, you don't want them to be exposed in a way. So you need to manually create the routes. So I have a green. Maybe I want to create a green route here. I want to create a green, and it's okay. So it's already creating. So if I access the green deployment here, voila, green. I have one which is blue, which is now is cyan, and the other is green, but it's not that useful because the real beauty is that you can dynamically change these routes. So I'm just going to create manually here in the console another route. So let's create a new route. I'll call that blue-green route. The path is that. And I'm saying that the blue-green route is going to route the request to the blue deployment, but it's also going to route the request to the green deployment. And I don't want that to be equal. I want 80% of the request to go to the blue. I want 20% of the request to go to the green. 20. In fact, I could do that, but yeah. I'll do another example first. So I have a blue-green deployment. If you access that, it's just going to the blue, right? So if you want to do basically blue-green deployment using a platform like OpenShift, you just have that. I'm deploying from blue. If I want to change I already deployed the green. I want to switch the router to the green. Just that. And I can just say to that, I can use just one single command. OpenShift and Kubernetes, they use a REST API with a JSON. So the things that I'm just sending JSON commands to my REST API, I can use this command, patch, saying that I want to change my route from the blue deployment to the green deployment. If I do that with just one single command, I can see that it's green. It was cached, okay? So now I'm doing green deployments. So I just need a one command and I already automatically switch deployment from blue to green. If I want to change it back dynamically, I just run the same command with blue. If I patch that, it's already back to the blue deployment. You see, if any of you ever try to do this kind of thing using like HA proxy, you know how hard it is to configure that properly with liveness and timeouts and everything else. So you need the CLI or you need access to the socket, blah, blah, blah. Reloading or restarting the HA proxy demo. With OpenShift, you just need a REST client. You just get a patch to dynamically change the route. It is already working. So you have blue-green deployments out of the box. If you want dump routing, dump A/B testing, that's the example that I'm going to show to you. So let's edit this blue-green route. Now I want to show, first it's going to the blue. I want to have another service to the green, and I want to handle 50, let's say 50. 50-50 to each one of them, because I'm assuming it's gonna be doing But if I hit here, you see that it sticks to blue because by default, OpenShift router is a stick. So if you have a client, it connects to one deployment, it will always get requests to the same deployment unless you configure that to be round robin. So to configure that to be round robin, you have to do this. You have to annotate to say the router, I want you to be round robin. Okay? But even then, it doesn't work on here the browser because the browser caches my requests. So if I want to show you really that is 50-50, I need to run that on the CLI, because then I'm gonna issue 20 requests and you'll be able to see that half of them are going to the blue deployment and half of them are going to the other one. I did half a half, I don't remember. 80? 80-20, okay, then it's correct. Yeah, because I was counting here, or maybe it's not 50-50. Okay, so 80% is going to the blue and 20% is going to the green. So you have automatically, very simply, you can do that through the interface in just an annotation. You could add a notation through the interface, but I wanted to use the CLI. So you can do that using OpenShift blue-green deployments and dump. When I say dump, it's because it's all that infrastructure can handle without business logic. When you have a dump A/B testing infrastructure out of the box. So you don't have to worry about Canaries because Canaries is a native Kubernetes feature. If you add the liveness check and readiness check, that's out of the box Canary implementation, because it's also the safest way to deploy into production. So that's just the basic. So let's try to increment our deployments here. I'll create another deployment. So just checking, I have a blue-green deployment. I have a blue, let's check my routes here, okay, just to show you. I have a blue-green route, which load balances between blue and green. I have a blue route, which just routes just to blue. I have a green route, which routes just to green. I'm going to add another one, which is purple. Yeah. Purple, and it's gonna be a purple deployment. Great. Why purple? Because I just have bad taste, right? And I didn't want it to be red, right? So I have blue, green, purple. So let's create a route for purple too. I want it to be called purple. So if I check here purple, DNS again. Oh, come on. So again. Purple. Oops. Something is not purple. I think I've deployed the wrong image. Okay. But, okay, just believe me, that's a different purple, okay? It's a special purple. And, right, I think I can change the image here. I can, because I want a different color to show to you, right? YANAGA, deploy master. Blue, this is real blue, not cyan. Which is new purple. Okay, let's check if it's the new purple is blue. Want to create a route, new purple. I'm just gonna, between that, I'm gonna add already the DNS. And purple. Purple, new purple. Okay, new purple is blue. Then I have a blue, which is cyan. I have a green, which is green, and I have a new purple, which is blue. Okay, remember the colors, because we're gonna do some smart routing with them. And so what I want to show here, I have a Zuul gateway running on my machine, Gradle. Okay. So Zuul, if you check out the source code on GitHub for the Zuul API, Zuul gateway, it's a very, very simple implementation. There aren't many lines of code. And it was very smart because if you check, maybe it's not fit for everybody because Zuul by default it loads the routing configuration from Groovy files, which are in the case of Netflix, since they use a Cassandra distributed storage. When you update the files on your Cassandra storage, the Zuul gateway automatically reloads the definitions every 5 seconds by default. So when you get to Cassandra, Cassandra distributes the files over the cluster, and when you get the new files, the gateway automatically updates the routing configuration. Okay, that's how it works, at least on Netflix. But for most of us, we won't have a Cassandra cluster just to distribute this kind of information. So if you're using Kubernetes, probably you use a Git repository, and for each change, you deploy a new version, because then you can use the Canary features of native Canary features of Kubernetes to check if your routing definitions are correct. Okay, so I think that's the safest way to be doing that. You want to combine Zuul dynamic deployment with Kubernetes Canary deployments to have a safe routing mechanism. Okay, because since it's Groovy and you're changing routes, something can go wrong. So I'm going to do here Zuul, which is very big here. If I go to localhost, my Zuul gateway is running here, and it's showing the green deployment because that's the code. That's what the code is doing. I want you here to show I have Zuul running, and since it's dynamic, what is it doing? It's blue-green. I want it to go to first. I want to route between blue, which is cyan. Oh, come on. Zuul. Oh, come on. It's not helping me. Right. Blue, and the other is green. Green is green. I think it's right already. So you see, it's just plain Groovy code, which is Java compatible. So you can write Java code here. So what I'm doing, I just create an atomic counter just to make sure that it will increase atomically. So if it's odd, it's going to blue, and if it's even, it's going to, or the opposite, it's going to green. So I'm gonna 50% of the requests I'm going to blue, and the other one I'm going to green. So that's the basic behavior of Zuul. So technically, if I just access my Zuul gateway, it should be rooting, but I just realized with Chrome it never works because it just caches the information. To make it work on Chrome, I have to open the inspector. I don't know why. Then it should be working. So it doesn't cache if you're using the inspector. So you open, so each time it does a new request, so you have green, then you have cyan, and everything else. So, but that's just basic. That's what OpenShift was already doing as an infrastructure router. So if you want to do something different, maybe we can add some features on that. So if I can add some feature, I could be queuing the session to check which user was logged in. If it was from this customer, I want to do that deployment. Another interesting scenario for this kind of A/B testing for deployments is that I have a bug that is only affecting iOS users. So I create a new deployment with that specific version, and I want to have the log with hundreds and hundreds of requests which are not iOS, because I'm just testing that bug. So I just want iOS users to go to the new deployment. So maybe I can add this header. I'm checking if the user agent contains iPhone. I want them to go to the new purple, or else I want them to be round robin between blue and green, right? So if I just save the file, 5 seconds later, Zuul will update the routing configuration, and if it's working okay, I should be. So if I have an iPhone, it should be blue, new purple, right? Oh, come on. iPhone, 5. What is wrong? Huh? Embrace? 14. Oh. I didn't even compile. No. What? Uncomment. Right. Application is not available. No, I just need to recompile, right? Oh, you're not coding very well. Come on. It's not. The deploy master? Oh, yeah, it's wrong. It's okay. It was on purpose, right? And and you have here, new purple. That's what happens when you change versions of your things on the day before. Oh, the purple is correct. Right. Then, if that's an iPhone, thank you very much. Merci. If that's an iPhone, it's gonna show you a new purple deployment. But if that's, for example, a Galaxy S5, which by the way is the version that still doesn't explode, it's gonna show you it's gonna be root between cyan and green, right? So that's how Zuul works, it dynamically. So you see, you can dynamically screw the things. That's why you should be using like Kubernetes to test your deployment, your Canary deployment before doing that. So you can programmatically change the target of your goals using a Zuul gateway. So people say that, oh, Zuul, that advanced thing, it's a very, very simple implementation just for you to be able to dynamically change the deployment that you're targeting the requests, okay? That's basically Zuul. Now I want to show you how feature toggles work. Here, I'll just close the Zuul application and of course stop Zuul. Now I have here my FF4J, which is just, this is just a Spring Boot application. So here I have a hello controller. So FF4J is a Java framework that just plugged. Everything you need to do is create a FF4J, an FF4J XML file and configure the dependencies. So FF4J, I'm just going to say, I'm going to have some features, toggles in my application. So I'm going to have a feature toggle called hello, and I'm going to create a new feature toggle called the new recommendation engine that we're going to implement here live today. So if I have hello, I will just create a hello controller to check to you, because the basic feature of FF4J, also a feature toggle sounds like a fancy thing, but it's just a dynamic if that you can change on a distributed system. So if I have a FF4J, I just check for the feature hello if it's turned on. If it is turned on, I reply hello, or else I'll reply bonjour. So let's run it. So I'm running the application, and everything goes okay. It's already running. And if I access localhost, now without the console, localhost writes hello. It says hello, but if I toggle it off, it will have to reply bonjour. Then if for that, I have a very nice console, which show my feature toggles, which are dynamically. You have two different types of deployment. You can have an embedded console, which is good for demos, but you also have a web application using a REST API, so you can add authentication and everything else, which is the thing that you'll probably be using to production. For now, also FF4J is storing all of my configuration in memory, which means if I restart, everything will be on by default again. But you have different kinds of storage. You can store the feature toggle information on databases, on Elasticsearch, on Redis, on Mongo, on in very different kinds of storage. So here, if I have hello, it's turned it on. If I turn it off, say it's already turned it off, and if I access that again, it will reply bonjour. Okay, it is replying bonjour. You say, oh, it's kind of silly. I could be doing that with other things, right? Well, feature toggles is basically you need a feature toggle framework to be able to toggle the features dynamically. So there's nothing much special about that. The basic usage is just adding some ifs to your code, but you can have more advanced features because you can integrate that with authentication, for example. You can create a release strategy saying that you want to group all of these features. Feature toggles must be toggled on at the same time, so you have a group toggle. It's possible to configure that too. So you can also have a release strategy. I'm saying that all of these new features will be available only after this time and date, so you can configure that. Your flipping strategy is also another cool thing. And if you're using Spring, at least you can use AOP with FF4J to dynamically change the beans that you're using into production. So I won't be able to show you because I'm out of time, but you can change here. I just saw the red. You can change the beans dynamically depending on if the toggle is on or off. So quickly, last thing, I just want to show the recommendation controller, because the recommendation controller by default is just showing you recommendations. It's just showing you these things: hamburger, hot dog, and cola. But because but I want to try to improve the users will be able to buy more. So I'm just gonna inject here. Oh, come on. Here, private improved recommendation engine. I'm gonna auto-wire that and say that just because I'm in a hurry. If FF4J check and FF4J, if the new recommendation engine is on, I want to return improve it, get recommendation, right? Or else the other one. So I just run and finish, right? Before they kick me out. Oh, come on, application. Then I have to create a bean. Oh, just because I'm in a hurry, I'm mistyping. Return new, improve it. Then at bean, okay, run. So it's running. If I get recommendations, now it's turned on, it gets much better food. In fact, the croissant, the fromage, le vin, ici, c'est très bien. And that's how you get, but if you turn it off, it gets back to a hamburger and something or else, okay? So that's what I wanted to show you today. Thank you. Thank you very much.